All right. Hey, everyone. Thanks for tuning in. My name is Solomon and still working on the title, but right now I'm going with foundational calculus with Java. So if you're anything like me, if you're a computer science student or really any student where you have to take calculus at some point, at college level, you may have struggled. Personally, I'm ashamed to say I have failed calculus in the past. Fortunately, I've learned a bit from those mistakes in the past. Uh, After a while, I came to realize I didn't really struggle with calculus. I actually struggled with algebra beyond, your basics, finding, the slope of a line or uh, plotting points on a graph, the quadratic formula, those sorts of things. Um, but once we got down into some of the more advanced topics, things that you see in Algebra 2 and in Trig, I realized I really didn't have a strong foundation in those concepts. Uh, but I guess it's sort of ironic. I actually had a pretty easy time learning programming over the years. And I've recently figured out a way to kind of tie the two together. Um, and that's what I'd like to show today. So without being too wordy, I'm going to jump right into it. So first things first, I'm going to be relying on this open courseware Calculus Volume 1 book. I'll leave a link in the description. It covers differential and integral calculus, completely free. Uh, Sort of a non-commercial license, so you can, I'm not sure of all the terms, you can read up more about it on your own time. You can also get this in physical print if you're interested. You can buy a print copy. And I'm going to focus primarily on some pieces of the first chapter, um, primarily dealing with functions. Um, Now, before I jump right into this, I'm just going to go over a bit more of what I'm using today. So I'm going to be writing all of the code in Java. I'm using a free tool called JGrasp. Some of you may be wondering, well, why don't you use IntelliJ? You can use IntelliJ if you want. You can use VS Code. It's totally up to you. I prefer this because it's just, I had to use it for a class before. I'm pretty comfortable with it, but you can follow right along in, NetBeans, whatever you like. It's not important. The most important thing is that you're able to make this connection. Once I was able to connect the dots, things got a bit easier. So I'm gonna jump right back. So I'm using JGrasp. I already said that. Uh, yeah, so let's jump right into it. So as a basic review of what you're going to go into with differential calculus, um, everything that you see here outlined is essentially what you learn in pre-calculus. But if you've never taken a proper pre-calculus course, or maybe you weren't taught properly, or maybe it was just a very fast-paced course, you may have not had much time to really digest a lot of these things. What is a function? Uh, Basic classes of functions, what are trig functions, inverse functions, all that good stuff. You can read up more here. I'm going to focus basically on what a function is and how we can connect this into the programming world. So I'm going to read this verbatim. A function consists of a set of inputs, a set of outputs, and a rule for assigning each input to exactly one output. Uh, so to put that more plainly, a function, you can think of it as a relationship, right? Where every input that you bring into this function is going to have exactly one output. Uh, and we we sort of refer to this as, let's say, it would be f of x, for example, or g of x, some function of x. Um, so what I'm going to do is I'm going to provide an example in code, and hopefully that'll connect some dots because for me, it never fully clicked until I was able to make this connection. So without further ado, let's go ahead and get started. So the first thing I'll do is create a class called calc. You can name the class whatever you want. I'm going to call it calc because one, I've already got the file created with that name, but two, it reads well. Um, so of course it wouldn't be Java if we didn't have our public static void main. string args, and I'll just skip a quick recap of what this is. Once again, I don't want to make any assumptions about anyone's level watching this, so I'm just going to try to tie in what things are here and there. So, keyword public, this is a public method, right? So it can be called anywhere in the code. You can I'm gonna leave some more discrete links that are helpful. There's a really helpful channel called Bro Code, where he talks about a lot of these things in like 10-minute, 8-minute videos that are uh, really easy to follow. It's a static method, meaning you don't have to create an object to call this method. Void, this keyword means this is re what this function is going to return. So sometimes if you want to return, an integer or a string or something like that, in this case, it doesn't return anything. It's funny when I first started learning programming, when I saw the word void, I thought that that was a verb. I know that doesn't make much sense, but I started programming on the Arduino, and some of the basic helper functions, are type void. So when I when I was just sort of teaching myself, I thought void meant to do something, like how one would void a check. But no, it just means that you're not returning a value. Main, and this is the name of our function. In Java, the center point of any program is going to be this main function. Um, And now this string args, string is the type associated with this argument called args. So from the command line, you can pass in arguments to a function, and that's what this is. This is going to be an array of strings that we refer to as args, short for arguments. Right? So let's just do a very basic system.out.println just to make sure we've got everything working. And by the way, guys, I'm using Java version 22. Uh, I haven't spent much time thinking about, um, compatibility, but if you have any issues, guys, anyone watching, feel free to let's make this like a community thing. So if someone has a question, you have the answer, just drop a comment. Let's work together, right? Let's not be know-it-alls and let's just work together to figure this stuff out. So I've got this saved here. I'm going to compile, build, and run it by using a shortcut, Control R. I'm on Windows, so let's see if I've got it working. Boom, no errors. Looks like it compiled all right, and we've got our hello world. Awesome. Okay, so we've got our class, we've got our first method. Now, what we want to do is we want to create another function, right? And this is where we're actually going to tie in um, excuse me. Uh, this is where the math comes in. So we're actually going to create a function like the one that we see here, f of x equals x squared. But in our case, we're going to start with a linear function and keep things a bit more simple. Like let's do something like I'm going to remove this. F of x equals 2x plus 1, right? So this is going to be a linear function. All right. So this is also going to be a static function. I'll explain why in a bit. Uh, it's not terribly important, but the reason why I'm creating a static function, um, I don't want to go overcomplicate things by having to create objects. So we're going to try to keep this as neat as possible. Um, So we want to return a double. You can use a float as well, but for the sake of precision, we're going to stick with a double. And the name of our function is f. All right. So what this is saying is that we've got a public um, function, meaning that it can be called anywhere in the program. Static, meaning we don't have to create an object in order to invoke it. And this double is what it's going to return. All right. So let's continue. So we're going to create this method so that it looks, or I should say it behaves just like this expression here, 2x plus 1, right? So our f of x is going to take an argument called x, and we want to be specific, it's also going to be a double. And what it's going to do is going to return a result that is equal to 2 times x plus 1. And then we're going to return the value of that result. So one thing I like to do, I like my comments to be just nice to look at, you know. If you've ever used the Laravel framework, and some of the built-in code, their comments look a bit like this. It just makes it, you know, nice to look at, nice to read. So I'm going to do that same thing here. And I'm also going to make all of this code available in the description, going to be on GitHub. So this is where things like domain come into play. So just going to make one more extra line here. Okay, so let's go back and remember that our domain um, are all of the possible inputs that can go into a function that won't break it. That's the best way I can think of it. So the fun thing about linear functions is we can put in any real number and we're going to be just fine. So I'm going to make a note here that says linear functions have a domain of all real numbers. And this is just a note to ourselves, just to remember that this is a linear function for one, and the domain of this function is all real numbers. So we've got our method here, we've got our main. The next thing that we're going to do is actually call this function. Now, we want to make this a little bit interactive, so I'm going to include uh, a few packages that I want us to use. So the first is the built-in Java util scanner. Whoop. And this is what's going to allow us to input values from our keyboard. Um, so that's the only module we'll worry about for now, but just be aware that there's going to be a few more that we add. So we can call this function. The first thing that we're going to do is prompt the user. So we will do a system.out.println, and we're going to tell the user, please enter a value for X. All right, so I'm going to save and I'm going to run. Um, so just so everyone's aware, if you're using the same tool, you go to build and then you just do run. Shortcut is Control R. So I'm going to do just that. Just checking for errors, typos, anything. All right, and we're all good. So no errors, and it's telling us to please enter a value for X. So the next thing that we'll do is actually listen for user input. So uh, we're going to create a scanner, KB short for keyboard, equals a new instance of the scanner class. And it takes one argument, system.in. Looks good. And I'm just adding another comment. Enter value for X. There we are. Now we've got this value here, but we want to actually go ahead and store it in uh, in an actual variable that will then pass into this method. So before this prompt, I'm going to define another double called x. And I'm not going to give it any value just yet. We're just going to have it available for when we need it. I think I may need to capitalize that. Nope, no, I don't. Okay. So now what we can do is we can then take the number that the user enters and store it inside of this x variable, right? So, okay, going to save and then recompile to make sure nothing's broken. Good, we're still here. So now if I enter the number 40, there we are, no errors. So we are good so far. Now let's execute function. Oop. So now what we're going to do is we're going to take that user input. We've already stored it inside of our variable. So the next thing that we're going to do is actually call that function that we're calling f. And we will do this by, I'm actually going to create another double for our answer. There we go. Okay. And now we can assign a value of f of x. All right. And then assuming everything goes well, we can print out the value. So f of x is equal to, and then the value of our answer. So save it. Let's build. Any errors? Whoop, I'm missing a semicolon. Save it again, rebuild it. All right. Please enter value for x. Let's go with 20. F of x is equal to 41. Let's make sure if that's true. So f of x is 2x plus 1. We've entered 20 for our value of x. 2 times 20 is 40. 40 plus 1 is 41. There we go. So far, so good. So we've just shown that we can take an algebraic function and program it in Java. So I know we're off to uh, a bit of a long start here, but this sort of made the connection a bit more real for me. So from here, we can continue into um, things that are a bit, you know, a bit more advanced, like quadratic functions. We're going to touch on composite functions, and we're going to keep going. Uh, so now, hopefully, the wheels are turning a bit for you. Um, so what I'm going to do now, let's say we want to create a quadratic function, right? So I'm going to create a new comment, and let's say quadratic function. And let's think of an example for this. We can do something like, okay, we can have let's say we have a function called g, right? So g of x equals, and we can do something like x squared plus 4x plus 3. And I've got a few things just handy to copy and paste. Okay, so g of x equals x squared, excuse me, minus 4x plus 3. All right, so we can actually go ahead and then find our function, public, static. Once again, we're going to use a double, and we're going to name our function g. It's going to accept one argument of x, and just like linear functions, quadratic functions also have a domain of all real numbers. A domain of all real numbers. And again, why is that? We can, any real number plugged into this equation, for example, this x squared minus 4x plus 3, you're not going to get an undefined value. Um, so let's go ahead and build this out. just to show just another proof of concept. So much like our linear function, we can do something like this. So double result oop, is going to be equal to x squared, which is the same as x times x, minus 4 times x plus 3. And then we can return our result. Boom. And that's our quadratic function. So now what we can do, we can scroll down to our main, and instead of executing f of x, we can go on ahead and execute g of x. So I'll save it, rebuild it. All right. And let's go ahead and enter that same value. Remember the last time we entered 20 and our result was 41? Let's see what happens if we enter 20 now. All right, g of x is equal to 323. And we can check our work. Looks like it's consistent with what we've gotten written. All right, so now we're going to get into the part that really sort of shook me up a bit. So when we actually get a bit later into calculus and you start dealing with limits and continuity, um, it's very, very important to have a very solid understanding of the domain of a function. So there are three things that you have to watch out for, which can result in an undefined uh, value at a given domain. So let me show you what those big three. So number one is division by zero. Anytime you see that there's a division by zero, it's going to return undefined, right? The second one is if you try to find a square or an even root of a negative number. And the third is if you try to find log of x that's less than or equal to zero, where the value of x is less than or equal to zero. So these are the three things to look out for that'll result in undefined. Uh, these are foundational, and by that I mean uh, once you start seeing your trig functions and any crazy equation where you've got things all over the place, just remember these three things. If there's division by zero, if there is a square or even root, and by even root, let's say if this were a four, or a six. So any even number outside of that radical, if it's trying to find a root of a negative number, it's going to be undefined because remember, a negative times a negative is a positive. So just keep that in mind. And lastly, to try to find a log of a value that's less than or equal to zero can't be done. It has to be positive. So let's go ahead and demonstrate that. We're going to create a few more functions here, and we are going to start with, and I just realized I skipped over the composite function, but we can come back to that. Um, so I'm just going to make it to do, and I'll keep that in mind. So the next thing that we'll actually have a look at is, I want to make sure I'm on track. Okay, so we are going to use a rational function. And more specifically, we are going to do a quotient function. So that can be something like f of x is equal to, and I like this x squared. So let's say f of x is equal to x squared minus 9 divided by x minus 3. So remember those big three. So if you'll notice here, we've got division, and there is a possibility that there can be a zero in the denominator. So we have to keep that in mind, and that is where we're going to have an undefined value. So let's go ahead and create another static function, and we can go ahead and just call this quotient, or actually, let's call it rational. All right. Um, just like the others, we are going to take in one argument, double for x, and all we're going to do here is just code this out. So once again, we've got our double result is going to be equal to x squared, which is the same as x times x. Um, Now, there is a math package that we could use that will just give us a function that'll make this a bit easier, but I really want to drag this out um, just to show, really to drive the point home, if that makes any sense. Feel free to skip forward or speed this up if it's a little slow for you. Otherwise, let's just do our best to get on through this. So let me make sure I've got the correct amount of parentheses. And looks like looks like we've got an extra. Okay, x squared. There's our x squared minus 9. Good. Divided by x minus 3. And then we will return our results. Now, before we actually test this out, we're going to have to manually check for this condition of the denominator being equal to 0. So if we just look at this, um, under what circumstances will this denominator be equal to 0? So just basic, arithmetic. If x is equal to 3, that is the only case where this will be 0. So we have to create a condition that'll catch that. So if the value of x is equal to 3, then we will have an error. And I'm going to go ahead and just create a comment for error handling. So if x is equal to 3, we actually want to throw an error out. So we'll do that by system.error, dot print line, and we'll define this ourselves. Let's say math error division by 0 is undefined. And then we can go ahead and exit the program. There we are. Okay, so I've saved it. I'm going to go ahead and recompile. It's going to try to run the same method as before, which is fine. Cool, nothing's broken. So we can go back into our main function and make sure that we're calling our rational method. So instead of g of x, we are going to do rational of x. There we are, saved it. So I'm going to clear my terminal and let's run it again. Control R. Okay, some value of x. So I'm just going to enter the number 10. So the rational of x is equal to 13. All right. Now let's try that again, but this time let's enter a positive 3 and see what happens. So I'm going to clear this one more time. Control R, value of x. And we've got our error. Division by 0 is undefined. So if we were to graph this, uh, if we were to plot this on a graph, we would see a discontinuity where x is equal to 3. All right. So that's an example of our rational function. So let's continue with another type of function. Um, so we can go right ahead into transcendental functions. Specifically, we're going to look at a logarithmic function. So As a review, what is a logarithm? So a logarithm is essentially just the opposite of an exponent. So the same way that multiplication is the opposite of division and addition is the opposite of subtraction, um, when you perform or when you have a logarithm, that is the opposite of an exponent. Exponents cause things to grow very rapidly, and logarithms cause things to do the exact opposite of that. So let's say f of x is equal to the natural log of x. Just keep it simple. Let's go ahead and create a function that does just that. So public static double, and we can call this log function. And hopefully you guys, are picking up on the pattern here. So we'll pass in a double um, for our x argument. Now, in this case, we actually will need to rely on an additional package. So in addition to the scanner as a review, so we're using this to handle our user input. Um, Now, we are also going to use port java.lang.math, and this is a built-in module or package. I've got Python on the brain. It's a built-in package that's going to it gives us a lot of built-in math operations that we can use. So we can do this very simply by saying that our result, which will be a double, and we'll have that equal to math.log of x. And then we will return our results. Now, once again, before we continue, we want to make sure that we check for errors. But I'm going to do this a bit differently. So the first thing I'll do, I'm scrolling back into our main method here. Instead of rational, let's go ahead and call our log function, save it. Now I'm going to go ahead, clear my terminal, and run this again. Okay, so what's the natural log of 100? All right, and it gives us something roughly 4.6, right? All right, perfect. Now, if I run it again, let's see what happens if I enter zero or a negative number. There we go. So it's equal to negative infinity. If I try it once more, if I try negative 45, we get a not a number error. So in either case, um, this would show as a discontinuity on the graph, either a discontinuity or an asymptote. I'll have to double check on that. But the most important piece to remember is that when we have a zero or a negative number here, it's going to give us results that we don't want. So let's go ahead and check for that error here. So if, let me go back up here. So if x is less than or equal to 0, then we'll go ahead and throw an error. And we can say, let's say non-positive numbers are undefined. And once again, we can exit the program with a code of 1, showing that there is an error. And now, if I save it and try again, if I set x equal to 0, then we get our friendly error and the program terminates. Logarithms of non-positive numbers are undefined. So that's 0. Let's try again with a negative number. -1. Got the same error. Perfect. Okay. Now, the last type of function that we'll look for is a radical function. Now, near radical, just remember, uh, I can't think of a mnemonic device for this, but uh, if you see the square root symbol, you're dealing with a radical function. Okay, radical function, let's say f of x is equal to, and now let me go back to copy and paste. So f of x is equal to the square root of x plus 1. Now remember our big three rules. So I'm going to go back and we've got a radical. So if we've got a square or an even root of some negative value, we're going to get an undefined result. So let's just think for a moment. In which case will this expression be equal to 0? So if x were equal to -1, then that'll give us our 0. So let's go ahead and write out our function, public static double, and let's name this radical. Once again, we're going to accept a double as our argument, such that um, just in case x is a decimal, you never know. So in this case, result will be equal to math dot square root, and we can just directly pass in x plus 1, just like that. And then we can return our result. All right, save. So before I add our error handling, I'm just going to save and recompile, Control R. Now let's say if I enter 99 as the value of x. Whoop, forgot one other piece here. We're still calling that log function. Let's go ahead and make sure that we're calling our radical function. So save, let's try it once more. Okay, please enter a value for x. So if we enter 99, then we get 10 because 99 plus 1 is 100. Square root of 100 is 10. So let's go ahead and add in our error handling here. So we've determined that if x is equal to -1, then ooh, I completely was incorrect here. So I'm still thinking of logarithms. We want to make sure that this expression is not a negative number. 0 would be just fine. But if it were, let's say, some negative value, then we'd be in for an issue there. So let's instead do something like this. So if x plus 1 is less than 0, and that way we'll catch anything uh, that may cause an issue. System.error.println math error square or even roots of let's say of negative numbers are undefined. And we can go ahead and exit that one. There we are. So I'm going to save, clear this out. Let's try this one more time. Okay. So now if I enter -1, then we're in good shape. Because the square root of 0 is still 0. However, let's say if I enter a -2, then we'll have our undefined. So now, going on back, the last thing that we'll touch on is a composite function. So let's say you've got something like, actually, let's stick with this line. I'll just remove that. An example of a composite function would be something like f of g of x. So I'm sure you've all seen this in, basic algebra. Uh, but you'll find these come up quite a bit all throughout calculus, and it's pretty important to know these like the back of your hand. So let's call this a static double, and let's call it composite. Now, this function is going to be a bit different from the others because we're going to accept three arguments. Uh, and we're also going to use an additional uh, piece to help us out. So we're actually going to use the functional interface, and I'll explain why. Um, so with this method, we're going to pass in two functions as arguments, uh, whichever function we want to use as our f, and the function that we'd like to use as g. Now, the first argument that we'll use is x. We've been doing that up to this point. Now, before I pass in the other arguments, I want to make sure that we've included our last package. So we'll include java.util.function. There we are. Okay, so got that saved. And again, you can read more of the documentation. That'll be included in the description as well. So that's our first argument. Our second argument is going to be some function f. So we would we'd reference that function interface, capital F. And it's going to take two arguments. The first is going to be uh, the type of our input into that function. And the second is going to be the return type of this function. All right. And we're going to name it f. And then we'll do the exact same thing and name it g. So this composite function is going to accept some value for x. It's going to accept some function for f, and it's going to accept some other function for g. Now, both functions will accept a double as an input, and they will both return a double as an output. All right. So what we can do first, let's work through this. So I'm going to add another one of these fancy comment blocks just to keep things clear. So what are the steps that we'll want to go through to actually solve a composite function? So we'll want to work from the inside out. First, we'll want to determine the value of g of x, and then we'll take that value and then run it through that function f of x. So I'm just going to make that note. Work from the inside out. Okay. So first, once again, we'll calculate the value of g of x. Okay. Second, we'll plug that answer into f of x. And lastly, we'll return the final value. Okay, so let's go ahead and do this. So the first thing we'll do is we'll create some double, and let's go ahead and phonetically spell out g of x. And that is going to be equal to g dot apply x. And just going back to the documentation, uh, there is actually a built-in method called apply. And what it does is it invokes that particular method, in our case, g. All right. So this is doing just that. This is going to calculate the value of g of x. All right. And let's keep this just clear for the end user. So let's go ahead and print out something like the value of g of x is, and then we'll concatenate g of x. There we are. Now we can go ahead and do essentially the same thing for f of x. And then we'll do f dot apply, and then we'll take our value from g of x as our argument. And then finally, we'll return f of x. There we are. Okay, so now it's going to get a bit messy, but bear with me here. I'm going to go ahead and comment this out here just because we're going to do this a little bit differently. Okay, so now I'm just going to make a comment here. Posit function. Okay, so we've already got answer defined. So I will say that our answer is going to be equal to, we'll call our composite function. Remember, the first input is x. The second input is going to be uh, our f function. So if we remember, we've already got one called f, so let's go ahead and use it. And the beauty of these being static methods, we don't have to create objects. We can just call the class, or I should say mention the class, and then the method that we want to use. All right. And for our last argument, we can do the exact same thing. And that's all there is to it. So the last thing that we'll do is print it out. So f of g of x is, let's say, equal to, and then we'll concatenate our answer. Okay, so now that that's saved, let's go ahead and clear this out, and let's try to run it one more time. Okay, what am I missing here? Cannot find symbol on line 98. Looks like I'm missing a letter T. All right, no problem. Save, clear, and let's try one more time. Okay, let's say we want to enter the number 5. Okay, so g of x is equal to 8, and then f of g of x is equal to 17. All right, and the beauty of this, we can use any of the functions that we created above. So let's say instead we want to use our rational function and the log function. We can do that just by swapping this out. Rational, and then what's the other log function? Oop. And the beauty of this is that all of the error handling is being taken care of within all of the respective functions. So if we come across, or excuse me, if we encounter an issue with, you know, trying to divide by zero or, uh, trying to find a square root of a negative number, it'll catch that for us. So let's go ahead and run this one more time. I'm just going to enter some arbitrary number, 35. Okay, g of x is 3.5, and then f of g of x is 6.5. So let's try to break it. So we'll remember that g of x is executed first. So let's try to think if we wanted to break this log function, if it's less than or equal to 0, it should break. So let's go ahead, run it one more time, and let me enter -5 and see what happens. Boom. Math error. Logarithms of non-positive numbers are undefined. Okay. So, and then we can do the same for the rational. Let's see. And in this case, if x is equal to 3, it should fail. So let's clear that out. Try it with the number 3. Oh, looks like that did not fail. And you know why that is, because the result from g of x is not equal to 3. But assuming that we got our answer of g of x equal to the number 3, this would fail. So we can even, if we reverse these two, uh, then we can go ahead and get that to fail just for the sake of demonstration. All right, so save. Let's run it one more time. And this time for x, let's enter 3, see what happens. Division by 3 is undefined. So I hope this has been helpful in some way. I know it's a little maybe a little backwards for some of you, but for me, I found this to be helpful. Remember these big three: division by zero, trying to find a square or even root of a negative number, and trying to find the log of a number that's less than or equal to zero. This will hopefully help you in your math journey. All the links will be in the description. Uh, I'll be sure to include a link to this book as well. Very helpful. Tons of practice problems. Sweet. Any suggestions or ideas, leave them in the comments. Thanks everyone for watching. Take care.